Hi, my name is Amish Srivastav, and in this video I am going to talk about reinforcement learning. The agenda of this video is: where does reinforcement learning fits in machine learning paradigm? What is reinforcement learning? The concept of reinforcement learning or Q-learning and how this works in the background. And finally, a quick Python implementation. Before we proceed, let's have a quick look at the definition of machine learning. One of the many machine learning definitions, which according to me is the most suitable definition, says the field of study that gives computer the ability to learn without being explicitly programmed. Consider a scenario where there are a huge number of states and actions or conditions. It will be very difficult to program them all. In this situation, there will not be anything better than a computer program which can learn itself and take appropriate decisions. There are three machine learning paradigms. Number one, supervised learning. Number two, unsupervised learning. And number three, reinforcement learning. In this video, I will not discuss supervised and unsupervised learning, but will keep my focus on reinforcement learning. So, what is reinforcement learning? The definition says it is about self-learning which enables a program to take suitable action to maximize reward in a particular situation. This is based on reward and punishment strategy, where the program or agent receives a positive feedback or reward on correct and expected action and receives a punishment or negative feedback on a wrong action. Further, these feedbacks are used to make right decisions. Let's try to understand this in the next slide. This is the typical frame of reinforcement learning. Here you can see an agent takes an action in the environment and then gets next state and the reward. According to Wikipedia, an agent takes actions in an environment which is interpreted into a reward and representation of the state, which are fed back into the agent. Let us try to discuss this using an example. Consider this network or topology where the blue nodes represent different locations and green nodes represent the destination. Now the agent might be at any given locations and its ultimate goal is to reach to the destination through most suitable way. What I mean by most suitable way is, let's say the agent is at location 2. Then for it, there might be 3 ways to go to the destination. And those will be from 2 to 1, 1 to 0, 0 to 3, and then finally 3 to 4, or from 2 to 1, 1 to 0, and then 0 to 4, or directly from 2 to 4. Here, 2 to 4 will be the most suitable way. Now, how will the agent learn it? For this, we implement Q-learning. What Q-learning algorithm says? First, initialize reward matrix based on known rewards and conditions. Then initialize Q matrix. Next, choose a state randomly. Then choose one possible action from state selected. Perform action, evaluate reward, and update the Q matrix. This keeps iterating until the agent is well trained. So let's initialize our reward matrix. Here, the horizontal axis shows actions and vertical axis shows states. So there might be 5 states from 0 to 4, and there will be 4 actions again from 0 to 4. So let's talk about state 0. If the agent is on state 0 and the agent goes from 0 to 0, that is not appreciated. Hence, we put a -1 here. Next, if the agent tries to go from 0 to 1, that is a valid action. But since it is not achieving the ultimate goal, we will put a 0 here. Again, from 0 to 2 is not possible. We put -1 again. From 0 to 3 is also possible. So we put a 0 here. And if the agent directly goes from 0 to 4, that is the most suitable path. So the reward value will be 100 here. Similarly, if the agent is on 1 and it tries to go to 0, that is possible. So we put a 0 here. 1 to 1 is not appreciated. So we put a -1 there. 1 to 2 again is a valid path. So we put a 0 there. 1 to 3, there is no direct path there. So that is again invalid. So we put -1 here. And 1 to 4 also is not possible. So this also is -1. Similarly, we calculate for other states and actions. If we talk about the last state, that is 4. So we do not appreciate any action which takes the agent away from 4. So that's why you see all -1 values here. But here moving from 4 to 4 is possible because this action is again will take the agent to the ultimate goal. So we put 100 here. So the reward point is 100 here. So this is how our R matrix or reward matrix will look like. Now let's initialize our Q matrix. So here we have both the matrix R and Q, where Q is initialized with zeros. Now we will calculate Q values using Bellman equation, which looks like this. Here Q S, A is the existing Q value, and Q dash S dash, A dash is the Q value of action A dash from the next state S dash. Max of Q dash S dash, A dash is the highest Q value among next possible actions from the new state S dash. This value is multiplied by a parameter called gamma. This is also known as discount rate, which ranges from 0 to 1. If discount rate tends to 1, future rewards are given more importance. If it tends to 0, immediate rewards are given more importance. We'll keep it 0.9 here, which is a standard value. Similarly, you see another parameter, that is alpha, which is also known as learning rate. It is used for weighing different experiences. Higher value ensures influence of recent experiences in the estimations. Here we will keep it 1. I won't talk much about these two parameters in this video. So let's try to calculate Q values. So this is how our initial Q matrix or table will look like. Now using Bellman's equation, we try to calculate further values. So let's say our agent is at location 0, which is here. Now the possible actions could be either 1 or 3. Let's say our agent picks up 1. is again here in this equation. So now we are trying to calculate Q value for 0, 1, which is this one. Here, the existing Q value is 0. So you can see the value is 0 here. Then we'll put value for learning rate, which is 1, and multiplied by, within brackets, reward value from matrix R, which is this one, which is 0 here. So we put a 0 here. Then our discount rate, which is 0.9, multiplied by maximum of all possible actions from next state. So our next state here is 1, and all possible actions are these. But since all are 0, we will have 0 only. And finally, our existing Q value, which is again 0. So finally, the Q value comes up as 0 again. So our Q matrix will look like this. Similarly, let's take another random state 3. So if the agent is at 3, there might be two possible actions. Either it can go to 4 or can go to 0. So let's say agent picks up action 4. Then we need to calculate the value, the Q value for 3, 4. So 3, 4 means this value. All those values again. And the final calculation comes up as 100. So our Q matrix will look like this. Similarly, if we take another state randomly 0. So from 0, again there will be 3 options or 3 possible actions, either from 0 to 3, 0 to 4, or 0 to 1. So let's say our agent picks up action 3. So here you can see when we try to get the maximum reward from next action, it will be maximum from this row, which is 100 here. So based on this, when we calculate the Q value for 0, 3, it is 90, which is placed here. Similarly, if we calculate it for 2, 1, it will be something like that. And after 10,000 iterations or training, this will look something like this. Now we have trained our program enough. Now let's see how the program will take the decisions. So based on the final Q matrix, if our state is 0, which is here, then the selected path will be 0 to 4, right? Even if we check the Q matrix, if we say we are somewhere here, then the highest value is this. Means the highest reward is to go to node 4. Similarly, if we are at location 1, which is here, then there might be two possibilities. Either go to 0 or go to 2. Means either go from here or from here. So in both the scenarios, the reward is 90. So the agent can choose any of these two paths, and so on. Now let's try to see the same implementation in Python. So here, as you can see, first I import NumPy library, and define my reward matrix. So it looks like this. Then I initialize my Q matrix with all 0 values. My learning rate is 1 and discount rate is 0.9. My initial state is 0. I define a function called getStateActions, which takes state as an input and gives us a complete row for that state. From there, we pick up all the possible actions which are having Q value greater than 0. Then we get all possible actions for that state. Further, we define a function called selectAction to perform. So there might be, as you know, as we have already discussed, there might be multiple actions for a state. So the agent has to select one action randomly. So here we are selecting the action to be taken. In the next function, we are updating the value of Q matrix. So first we get the index of highest reward, and then we calculate our Q value. To train our agent, I am doing 10,000 iterations. So here you can see how my code will look like. Then finally, I am printing the Q table. The next row is to normalize the values. Finally, we want to test the agent. So let's say if I put my current state 0, now this section of the code basically tests the agent. So let's say first our state is 0, then what will be the most suitable path? So let me run the program. So here you can see my matrix would look like this, and the best path is directly from 0 to 4. If I make it 1 and run the program again, this will suggest from 1 to 2 and from 2 to 4. I do not make any change and try to run it again. Now this is suggesting from 1 to 0 to 4. And the reason of this is it has got equal rewards for both the paths. Now let's make it 3 and run again. So this gives us directly from 3 to 4. That's it for this video. If you have any questions or queries, please put your comments in the comments section. I will try to respond. Thank you.